All right, welcome back to day 2 of this loveliness. We are going to finish up section 10.2, dealing with the parabola, and going to go over a couple of word problems here. So we should be, you should have your guided notes. A couple of comments here. What I'm going to do is, since I'm not there and it's a little bit different situation, I'm going to try and do an answer key, or I'm going to do an answer key and post it at least for the first 2 or 3 days here. And I'm going to post it under modules. So hopefully you can follow on my screen here. And if you go to pre-calculus, and you go to modules, and we are in chapter 10. Now you won't see all of this because it is not published at this point, but you should see the first one, and then it'll say homework key, and that'll be available starting at the beginning of your class period. So first period, it'll be available at 7:39, so you can't see it before then, and then fourth period, it'll be available at 10:10. And so I go through the problems, or at least I have them written down. So you can look at them, and it might have a little bit more information to help you if you get stuck. I do want to talk about a couple here. If you came across on your homework a couple terms that probably did not touch it enough upon as I needed to, they talk about for number 23. Let's just take it. I'm going to do that one here. They talk about the axis is the x-axis. Well, the axis of the parabola. Okay, and they talk about two things. They talk in the homework, they talk about the axis, and then they talk about the focal diameter, and that starts with number 29. Well, for those, the axis is the line that contains the focus, okay, and the vertex. And it will always be perpendicular to the directrix, or the directrix is perpendicular to the axis. So the axis, again, contains the focus and the vertex, okay, and it'll split the parabola in half. So just to kind of a little bit of a clarification there. Let me see if I can get rid of it now. And then the length of the focal diameter is just the length of the lattice rectum. So you go from the focus 2A to the right and 2A to the left. And so your focal diameter will have the same value as the length of the lattice rectum. Now, typically I have you find the endpoints of the length of the lattice rectum, which is very similar to finding that length. You can find the length from there. All right, so those are two key things I just want to make sure I touched on. So for 23, the axis is the x-axis, and the graph passes through 3, 6. All right, so that means this cuts it in half, and from the directions of the problem, we already know that the vertex is at 0, 0, and it hits through the point 3, 6. The only way this could open is to the right. Okay, so that's the only way that can open. And so we want to find, what's it asked for? The standard equation. Well, since it opens to the right, it's got to be the form y squared equals 4ax. All right, so it's going to be of this general form, y squared equals 4ax. And it goes through this point 3, 6. Well, what we can do is we can plug in the values for x and y to figure out what a is. So 6 is y, x is 3, and so I get 36 equals 12a, and when I divide by 12, I get a equals 3. Now, since it opens to the right, a has to be positive. And so I get xy squared equals 4 times 3, which is 12x. And so that's going to be the equation for 23. All right, I want to go over that one. And I think from the answer key, you'll be able to kind of figure out the others. If not, I'll be back at some point, or send me an email. from here. All right, those are the homework assignments. Like you said, you should be able to go to the modules and right now check them. Even though the answer's in the back, maybe you couldn't get one, and it does have a little bit more work on there. Hopefully it can guide you in the right direction. Okay, back to your guided notes for section 10.2. Again, the directions say find the vertex, focus, directrix, and endpoints of the lattice rectum for the parabola and sketch its graph. All right, so we have the equation here. Y minus 4 squared equals 6x minus 1. First thing you should be able to identify, which way does this open? Since the y is being squared, it has to open left or right. And since this term is positive, the 6 is positive, it means it has to open to the right. So our graph needs to look like this. The vertex we can pull out from the equation. So it's going to be 1, 4. And now to figure out what the a value is, 4a is always equal to that constant. So 4 divided by 4, we get 6 over 4, or a equals 3 halves. Okay, for that one. So our vertex is 1, 4. Since it opens to the right, your focus has to be inside and your directrix has to be behind it. So that means we move the a value, the a distance, inside to get the focus. So I go 1.5. And there's the focus. And then I go 1.5 behind it. And then that's going to be the directrix. Now I'm going to draw it in with that tool. And so that's what it looks like. Now, we need to list the coordinates for the focus. Since the focus is 1.5 to the right, it's going to be 2.5, 4. Our directrix, remember it's a line and you have to label it as such. It's going to be it's a vertical line, so it's going to be x equals negative 0.5 or negative 1/2. All right, now our endpoints. Okay, the endpoints of the lattice rectum. Let me go back to yesterday. Remember, you go 2A, either up, down, left, or right, from wherever your focus is, 2A, so you double our A value. Our A is 3 halves. If you double it, that would be 3. And we got to go from the focus up, 1, 2, 3. And we go down, 1, 1, 2, 3. So the endpoints they'll both have an x coordinate of 2.5. So it's 2.5, 1, and then it is 2.5, 7, because we went 3 up and 3 down. Now, what's that distance of the focal diameter? You would just take 4 times 3 halves. It's going to be 6, so you can count that. Now, this kind of gives us the width of the parabola. It might not be my best. All right, so there's your parabola. You had to draw it. You had to sketch it. Since the y is the variable squared, it opens left or right. Since that's positive, it opens to the right. All right, so we found all the parts it asked for. All right, let's move to the second one. Now we're dealing with the cases where they don't give it to us in that nice form. Okay, they don't give it to us in that nice form. We have to make it in that nice form, where we can identify the vertex, where we can identify the directrix and focus. Now, for a parabola, only one of the variables can be squared. X is the variable is squared, y is not. So that means when we're done, it needs to be in this general form, x minus h quantity squared equals 4a times y plus k. Have you noticed over my grid, I already have it scaled. Just it's going to be a little bit easier if you make every 2 as 1 unit to spread this one out a little bit. Okay, so do that as well. All right, now what can I do here? Since this is usually on the left-hand side, I am just going to take this and I'm just going to flip the sides. So I'm just going to make it x squared plus 2x minus 1 equals negative 2y. All right, this is going to come up again here. To make a quantity squared, we have to complete the square. To do that, let's get this 1. You want to just keep the terms with the x's on the same side. So move the 1 over to the other side. So I got x squared plus 2x equals negative 2y plus 1. Now complete the square on the left-hand side, which means we're going to put in a number here. And then we got to put in the equivalent number there. And remember, you take half of the coefficient. Half of 2 is 1. You square it. And that is the number that will go into each spot. So now over here on the left, that gives me, after I factor it, x plus 1 quantity squared. And I simply combine like terms here, and I get negative 2y plus 2. We need to have it in this form. There needs to be a constant in front of the y plus k. The y, I do not want a coefficient. So whatever the coefficient is in front of the y, you factor that out. So it's going to be negative 2. Basically, you divide both parts by negative 2, and you get y minus 1. You got to understand, if you distribute the negative 2 back, you're going to get the original. All right, this right here, that is our equation. That is the standard form of the equation for conic sections. From here, we can get our information. Our vertex will be, the x part is first, is going to be negative 1, positive 1. 4a equals negative 2, which means a divided by 4 is negative 1/2. Now, let's take a look. Since it is x is the quantity squared and a is negative, that means it's going to open down. That means the focus will be inside of it. The directrix will be behind it. Now, I'm going to graph it, or start to graph it. So my vertex is at negative 1, 1, which is right here. All right, I need to go that a value to get to the focus. So at this point, I really don't worry about the negative in front of the 1/2. That just tells me whether it opens up or down. So I'm going to go down 1/2. That gives me the focus, and then I'm going to go up 1/2 to get the directrix. So now I got the focus is at negative 1, 1/2, and the directrix is at, it's an equation, it's a line, so it's y equals, looks like it's 1/2 or 3/2, so y equals 3/2. Now I need endpoints to lattice rectum. Let me do this. Okay. How far do you move from the focus? In this case, we're going to move left and right. Well, since a is 1/2, you're going to double that, which makes it 1. So you want to move 1 to the right, and you want to move 1 to the left. And so those are going to be the coordinates of my lattice rectum. So it's going to be negative 2, 1/2, and it's going to be negative 0, 1/2. Remember, the length is 4a. 4 times 1/2 is 2. So it should be 2 between the focal diameter. Okay, for that. All right, so we found all the key parts. We sketched its graph. All right, take a look at this one here. Again, we want to come up with all the key points as well as sketch its graph. You always have to look, especially when you get to ellipses and hyperbolas, what's being squared. This only has the x being squared. Get every term with the x on one side, move everything else over to the other. And then now, you cannot complete the square. That should be minus 8x. You cannot complete the square until that is just an x squared. Well, since I'm working on both sides of the equation, what I can do is I can divide everything by 2. And so that gives me x squared minus 4x equals 3y plus 5. Now, and only when that is there's no coefficient in front of there, only then can you complete the square. Now remember, you take half the coefficient. 1/2 of -4 is -2. You take that and you square it. And that's where we get this 4 and we get this 4. On the left-hand side, it should factor into a quantity squared, and it will factor into x minus 2 quantity squared. And over here, it's going to be 3y plus 9. Not done yet. You're not done until you get no coefficient in front of the y or the term on the right-hand side. So you factor out a 3, it becomes y plus 3. Now again, I would at this point say, all right, which way does it open? Since the x is being squared, it opens up or down. Since our a is positive, it's going to have to open up. That means my focus will be inside of the parabola. My directrix will be behind it. My vertex is going to be 2, -3. And then from there, so I'm going to go over 2, down -3, put a dot. My a value, well, 4a equals 3. That means a equals 3/4 or 0.75, whichever one's easier for you to deal with. You're not always going to get nice numbers with these. So that means I need to move up 3/4. I don't have a lot of room. So I go up 3/4 and then I go back 3/4 to get the directrix. So what I got now is my focus is, it's still going to have that same x coordinate. So it's going to be 2, and then I go up 3/4 from -3, so 2, -2 1/4. And my directrix is y equals -3 3/4 for that one. Now to get to the endpoints, remember you go 2a. From the focus. Well, 2 times 3/4 is 1.5. So I'm going to go 1.5 to the right, and I'm going to go 1.5 to the left. So my endpoints, since I started at 2, it's going to be positive 1/2. It's got to have the same y value as the focus, so it's -2 1/4. And then here I got, what is that, 3.5? -2 1/4. And now I'm going to sketch the graph through those points. So if you have something that's not in the nice form, number 1 was in the nice form. Okay, you had a quantity squared equals, you had the coefficient out in front and then your parentheses. So you could just pick off the vertex 1, 4, figure your a value out. The second and the third one, though, you got to do a little bit of work. We got to put it in that form so that we can find the a value, we can find the vertex, And from there, we can figure out the focus and the directrix. And then the third one, same idea, but you got a coefficient in front. So we ended up having to divide everything by that coefficient to make things a little bit easier. All right, now I know that was the end of your guided notes, but we got to do a couple problems here. I think you've got room on the back of those. We're going to do a couple problems from the book. So go ahead and pause this and get your book out and go to page 951. And it is the last problem of the page, number 69. This is a parabolic satellite dish, similar to the one pictured in the book. It uses the reflective property of a parabola. So any wave that comes in and hits the dish is going to be reflected to the focus. So we want to put the focus where all of those rays are going to gather. And then we can gather that and put it in as a signal. Okay, you see where the wire extends out of there. Well, the key thing is we got to figure out the focus of this parabolic dish in order to, collect the waves. All right, if you look here for number 69, it says a parabolic satellite dish is 40 inches across and 20 inches deep. I'll explain what that means in a second. Well, it tells you here, from the vertex to the plane of the rim. How far from the vertex must the signal receiving receptor unit be located to ensure it is at the focus of the parabolic cross sections? All right, then we want to make this as easy to work with as possible. So basically just take your dish and set it down like it's on the ground. And think of this as the x-axis. And let's put our y-axis right through the center. So right there, our vertex is 0, 0. You might hear Max in the background there. He's getting a little feisty today. So this is our rim. So 40 inches across means that from here to here is a distance of 40. When it says it's 20 inches deep, it says from the vertex to the plane of the rim. Well, the plane of the rim, so if you just think about that, so that would be like if you would draw that line, an imaginary line, that would be the plane of the rim. That is 20 inches deep. So basically from here to here is 20. Since I have let me extend that up just a little bit. Since I have the vertex at 0, 0 and I have it opening up, this can be in the form x squared equals 4ay. A tells us, the A value tells us where the focus is. Now, it may be inside here, it may be outside of here. Obviously, from the picture, both of them, it's outside, it's above that rim, but that doesn't guarantee it. Okay, that's just for that situation. But we need to find that A value. Well, here's how you're going to do this. I'm going to find a point on the graph. So if this is 20 inches high and 40 inches across, this point right here, and this is 0, 0, has to be 20, 20. So if I can use a point, and then I know it's in this format, I can figure out A. So take that form in the point 20, 20 and plug it in. And so it's going to become 20 squared equals 4 times A times 20. Well, what's 20 squared? That's going to be 400. And then 4 times 20 is 80. Divide by 80. I get A equals 5. That tells me, So how far must the signal receiving receptor be located to ensure this is the focus? So 5 inches from the vertex. Okay, 5 inches from the vertex. So we had to find that value. All right, now what I want you to do, we're going to do one more here. I want you to flip the page over and look at number 77. Okay, read through that one. I'm going to pause this for a second. All right, so hopefully you read through that. First time through can be a little bit confusing, but this gives you an idea what a suspension bridge looks like. You have your roadway right here, and then from the top of each tower, okay, you got a wire that will be a parabolic in shape. It's a little bit distorted because we're not looking at it straight on. So we want to make this as easy as possible when we look at this. So what do we have and what do we know? The ends of a suspension bridge cable are fastened to 2 towers, which are 800 feet apart and 120 feet high. All right, let's see here. Let's do this. That'll be one tower. That'll be the other tower. There's your roadway. Like halfway there. So this is the wire. We said it is 800 feet. The towers are 800 feet apart and then 120 feet high. Well, if I make this 0, 0, okay, that's going to give me the easiest form of the equation, which is, since it opens up, is going to be the form x squared equals 4ay. Now, let's see what they want. Assume that the cable hangs in the shape of a parabola and touches the roadbed midway between the 2 towers, which we did. Find the length of the straight wire needed to suspend the roadbed from the cable at a distance of 250 feet from the tower. So I'm going to go from a tower, I'm going to go over 250 feet. Oh, I didn't draw that very good. Oh, shoot. Hold on, let me delete it. So I'm going to go over 250 feet, and I want to know the length of that wire. Well, as you can see up here, look at all of these wires, okay? So we're just figuring out the length of the wire that is 250 feet. It looks like from the way I have it drawn from the one on the right, tower on the right. So this right here, 250. Well, we need to figure out the A value. We need to figure out the equation first, and then we kind of go from there. It doesn't ask us where the focus is. That's not concerned with that, but we still need the equation. Similar as the last problem. I don't know X, A, or Y. You need to use a point on the graph. And from the information we've given, this point right here is going to be 400, 120. Okay, the whole thing is 800. If I let 0 be right and a half, I'm going to go 400 to the right, 120 up. So I got 400, 120. So I'm going to plug this in, and I get 400 squared equals 4a times 120. Well, what is 400 squared? Okay, 160,000. 4 times 120 is 480A. Okay, so now A equals 160,000 divided by 480. Okay, now whenever you get a decimal like this, you do not want to round that off to 0.3. Now you can leave it as 333 and a third. You can convert it to 1,000 over 3. That is fine as well. So I'm just going to leave it as 1,000 over 3 reduced, because now we're dealing with the length of a cable. And if you round that off to 0.3 or even 0.33, then you are in danger of making this not the right length. And so now we want to figure out, so I got x squared equals 4ay. A is 1,000 over 3. And we need to figure out what this height is right here. I need to figure out the coordinate of the y coordinate of this point is. Well, what's the x coordinate I'm going to plug in? You got to be careful because you're not going to use 250. 250 is the distance from the tower. We need to know the distance from 0, 0. Well, since it's 400 total, that means this distance has to be 150. So that is the x value we're going to plug in. So plug in 150 squared equals 4 times 1,000 divided by 3 times y. Oh, what's 150 squared? 22,500. So that would be 4,000 over 3 if I distribute that 4, and I want to divide by 4,000. Hold on here. Oh, there it is. 4,000 divided by 3. So I get 225,000 or 22,500 divided by 4,000 divided by 3. And it's 16.875. And I'm going to keep that. So it's 16.8. I'm not going to round that off because it's a terminating decimal. Okay, so that's the answer to our suspension bridge problem. Homework, page 950. Okay, these problems here, I will put together an answer key as well, post that so tomorrow on Thursday that you can look up and see how you're doing. All right, hope everybody's doing good. And I look forward to seeing you as soon as I can.